Hello everybody, welcome to the Center for Off-Road Research, Shenanigans, and Science, and today I'm going to talk about crawler theory. We're always talking about our cars and how to build them and basically what to do to make them do what they do, but this is what is behind it, and I'm going to talk a little bit about my theory on how to make a good crawler. First thing we'll look at is the base, and this is your actual wheelbase, and at the point where the wheel touches the ground is the contact patch. You'll notice when it tips and rotates, it moves about that contact patch, and it doesn't matter what angle it's at, it's going to be from the axle straight to the surface. That's your contact patch. So as long as your center of gravity remains within here, or here, it will stay flat. When you lean it too far, it falls over. So an easy way to depict that is just showing the center of gravity here is within the wheels, and this is a side view, as if we're looking at it like this for the remainder of the drawing, and later on we're going to look at it like that. But this is climbing right here, and suppose we are climbing up a hill. As long as the center of gravity here, the black dot, stays above the contact patches of both wheels, and that gravity line, that center of gravity always pulls straight down towards the center of the earth. That does not change. Gravity is gravity. Centrifugal force is different. We're not going to deal with that in this talk today, but as long as you keep your center of gravity within those two contact patches while climbing, it will remain climbing. If you get too steep and the center of gravity gets so far up that it basically goes outside of the limit of the balance point. So your balance point right now is that back tire where it touches the ground, and the moment your center of gravity, this line, this black line, passes this here, it will tip over backwards. So that's that. So we'll look at why we add weight. When you add weight to the axles, you lower the center of gravity. Notice I only have 2 dots there. These lines are roughly the same. I've got 7 or 8 dots on the other side, showing a greater distance from the plane we are climbing to the center of gravity. By lowering the center of gravity, we can bring our gravity vector back within the wheelbase, and it will continue to climb. If we can't bring our center of gravity down, or we've already loaded the axles as heavy as possible, there is a way to deal with that, and that's to move the center of gravity forward. When you move it forward, you can see that that line goes straight down through the plane, and it's still up high, but it's so far forward that it keeps the center of gravity in between the wheels and within its balanced base. So that's why we move the weight forward. The problem with that is, if we move the weight forward like that for downhilling, the opposite can be true. And suppose we had our center of gravity here, it's way out now. I'll just draw that. This would be center of gravity for descending if the motor was forward right here. It's already greatly outside. So a truck that has a massive far forward center of gravity for climbing is great. It's fantastic. But you're going to give up a lot during descending. A low CG balanced one is really good too, because it will climb or descend the same, but it could do one or the other better if you move the CG in one direction or the other, forward or back. But that is the 101 portion of this. You can see why we like to lower the center of gravity and why we like to move it forward for climbing. The last thing we talked about was pretty simple to understand. This is a little bit harder, and it's not harder, it's just a little bit harder to conceptualize. So what I've done is I've drawn the rig, and I drew the front axle in black, heavy black, to represent a heavier weight and a smaller weight in the back, smaller tires. We weight the front axle for a lot of reasons. I'll show you the first one. When you're climbing over a ridge, sometimes you won't be able to keep the rear tire on the ground, sometimes you will. Hopefully you'll be able to push the front of the vehicle up high enough that it can then teeter-totter over. That weight will just pull the nose down, and then with more weight on the front and a light rear axle, the vehicle can pull itself forward. It can just drag itself over. If you had a very heavy rear axle, the front would not be able to tip forward, and it also would not be able to pull necessarily the weight of the rear axle over the ridge or the peak that you're trying to cross. There are other benefits to having a heavy front axle, and I will show you the next one with a demonstration in the next scene. What you're seeing here is a crawler that has the majority of the weight, and a lot of people go 60% in the front, 40% in the rear. I start there, but I don't leave it there. And what you're seeing here is a crawler that's stable and can actually hang a wheel, because the majority of the weight's in the front, and it stays within its front two wheels. It stays within its base. That center of gravity is within its base. If you overload a rear wheel or rear axle, the center of gravity moves back, and it's the same thing as adding weight, and it'll eventually get to the point where your truck could actually tip over. This one's inherently very stable because I've weighted a lot, but I do have other crawlers that have heavier weights on the back, and they'll actually tip if I were to push down that much. But this one is unbelievably stable. The Mofo version 3 crawler is incredible. But that is why, another reason why I like forward weight and not rear weight, because you can actually carry a single tire over a gap where it can't even touch anything. So honestly, you really only need to have, in this case, two wheels on the ground. And in the case of that new climb that I have, as long as I have something under opposite wheels, it'll still remain in position. The other wheels then just stabilize it. They don't actually carry it, but they're just stabilizing it. So if you have equal and opposite corners, you can crawl, or you can also, if you have a decent CG, can hang on the side like that too, but that's a little harder. Sustaining that's a little more difficult, but it can be done as long as your center of gravity is low enough. This is another reason to have a low center of gravity, because it gives you an extreme side hill capability. Next we'll look at downhilling, and once again the black represents a heavy front axle, the light circle in the back represents a light rear axle. And this is a very low center of gravity crawler, because most of the heavy stuff when it's running is down low. So I have represented the vehicle center of gravity down low, and you'll notice that it still has, in this case, the gravity line is within the wheels tipping points. And when I add weight to the back of my vehicles, I add just enough to keep this back end touching the ground. I don't add any more than I need to than what it is to just keep this thing from raising up and front flipping. So that's adding weight to the rear. Essentially, the more weight you add to the rear, the farther back and lower your center of gravity gets. It's good and bad. It can be bad. Remember, more weight in the rear prevents you from climbing as well over peaks, but it will increase your downhill capability. So everything's a trade-off. You have to find that place in your truck. And when we talk about tuning a rig, this is what we talk about. How do we make it work the best for the conditions we drive on? And that may be different depending on where you are. If you do a lot of side hilling, by all means, if you're never going to drop a hole or a wheel into a hole, weight the whole thing, front and back. If there's no holes, the lower you get the center of gravity, the better. Plant all 4 tires. But if you're going to do rock crawling and things where you're going over steep terrain, things like that, you're going to want a balance of that. So as always, the lower the center of gravity, the better. That goes without saying. The fastest way to do that is lighten the top of the vehicle, and that's where these bouncers are stellar, especially the slab-sided ones like this. They have almost no weight, and the only thing that has any weight at all is what you add. All that brass, everything down low. Anything down low is going to help pin it to the ground, and that's always the case. But as you saw before, how much weight you add to the rear axle will affect your side hill capability, your ability to carry a wheel over a hole, and your ability to downhill. The next thing we'll look at is wide track versus narrow track, and the obvious is clear. Your center of gravity can move a lot farther in each direction with relationship to how far it will have to get in order for that center of gravity to extend past the tipping point. And the tipping point is that dotted line around, and you can see that line isn't very far here, and it's a lot farther here. So that's the obvious benefit of a wide track. That's the only benefit, if you ask me. You get better side hilling, but there's a lot of negatives to it. A wide track is going to have a difficult time getting through narrow places because it's just too wide to do it. Also, if you're driving over a narrow ridge, you may not have enough terrain under the vehicle in order to drive on it, because if the ground's not as wide as the tires, it can't go there. If the tires are narrower, it can, as long as it can stay on within the boundaries of the road. It can also obviously go through holes that are smaller. Finding the balance between how narrow and how wide you want to make your truck depends on how and where you drive it. And what I like the narrow suspensions for, narrow tracks, is a lot of times I have diff clearance because both tires can touch and I still have the differential clearing a peak. And this just represents a hill or a rock that I'm going over, so it's able to clear. Now, when you widen your track, it does not change the distance between the axle, the drive axle that goes through the middle of your axle housing, and the bottom of the tire. That remains a fixed distance, unless you go with the bigger tire, which is going to raise your center of gravity. When you widen the tires farther apart, this distance has not really changed, but what has changed is the distance between here and here. And now the differential can actually touch, and this wheel may no longer be even on the ground because it's just too wide, and these arcs that I've drawn are relatively the same radius. So this is just driving over the same thing. You're gonna hit the differential and your truck will stop. So that's the first reason why I don't like wide as much. Now, if you go a little bit wider, it doesn't hurt things necessarily. It doesn't take a whole lot of widening to get a lot more side hilling capability. I found that out with the portal axles, and even with the positive offset rims that bring the tires narrower together again, It still has a little bit of a widening effect, but it's okay because we have effectively increased this number here, because now the axle will sit up here. So that's why you have a portal, is it raises the entire axle. But again, it raises the center of gravity. So is it worth it? Maybe. You can run a smaller tire and then without going to a big tire, and the portal boxes themselves will add a bit of weight. I'll draw that out real quick. All right, this is just showing a portal axle with the drop. There's a couple of gears in there. You got your normal axle, the drive axle that comes out of the housing that goes straight, and now you see the drop, and it comes out into the wheel. This is the axle shaft for the wheel. So you do get a little more center of gravity as far as increase in height, but these are heavy. I can't remember how much they are, but they were, I believe, 11 grams per side. So you're adding 22 grams of weight down low. So even though you're raising the axle up, the drive axle and the diff and the entire chassis by half a centimeter in the case of the SCX24, but you're adding that portal box weight, which helps bring the center of gravity back down. The only downside or upside that you have to consider when running a portal is a potential final drive change in the torque and wheel speed. The Mofo ones that I've installed increase the torque by 25%, which is significant, and I really like that, but it also decreases your top speed by 25%. So you're trading speed for torque, and it's not a lot. You can get it right back if you put a faster spinning motor in it, but that's why we use portals, and you can get that extra diff clearance without adding a bigger tire, because you just have changed the position of where the axle comes out of the final axle comes out of the axle housing. So that's the reason for a portal. I'll show you the last reason why I really like narrow as opposed to wide. For this next discussion, I'm going to draw on my background in aviation. Y'all probably don't know that I'm an airline pilot and also a flight instructor. I'm temporarily out of that for a little while and am driving professionally. And I'll just go with what I know, and it'll make sense in a minute. But we're going to use a twin-engine airplane here. This will represent our wide track vehicle. This will represent our narrow track vehicle. And as long as all the engines are running in both of these airplanes, and providing they're all providing an equal amount of thrust, this one will pull straight ahead with its single motor. It can only pull one direction because it has one thrust vector. A twin engine airplane has two thrust vectors, and as long as they're both pulling the same, the net result will be straightforward motion. It goes straight ahead, just like that. Okay? The problem happens when one motor quits. And in this case, the left motor is going to quit. I promise I'll tie this back in to trucks in a second. But you see now we have one thrust vector only. Okay? This represents our center of gravity. What must happen due to the laws of physics is that one motor will then rotate the plane about its center of gravity. All right, it's going to make sense here in a minute. Now we're back to our trucks. This is our narrow rig. This is our wide rig. Now you see wheels that are closer together are on a shorter arm length, and that arm length is the distance between the center of gravity and the center line of push from that wheel. We'll call it thrust because we call it thrust in the last one. I don't know what you call it, torque, force, whatever. Force, we'll call it forward force. Anyway, you have a narrow distance between the force and the wheel here, or the center of gravity. Here you have a long distance between the wheel and the center of gravity. that's all well and good, but what happens now when, suppose you high side a rock or an obstacle gets caught under right here. Suppose it's blocking your vehicle and you got these two wheels on the ground and the skid plates framed out. You're touching the ground. These wheels here are in the air and are no longer pushing. Okay, you're going to have a bit of a rotational force that's going to want to push the car sideways. Okay, now if you get any force at all from this side, it may be enough to be able to push forward and clear it. In this case, you have this wide, long arm. It's a long lever from that axle to the center of gravity. And it's really going to have a large force this time that's going to push a lot stronger to rotate your vehicle. And if you had anything here at all, any type of force that was starting to grab but it might not be enough, on this truck a small amount of additional thrust might be all it takes. On this side, that same amount of thrust isn't going to be enough to compensate for tires that are fully gripping. This thing is going to rotate where this one may go forward and rotate. It's just, I'm going to draw the arrows a little differently here just to demonstrate the pass. One is going to rotate fully and one of them is going to rotate and push ahead, which is what you need. So that's another reason why I like narrow track wheels. The last thing we'll look at in this video is my SC Enduro 24X. That's kind of what I call it. And the reason why it climbs so well is a lot of things. First of all, it's long, and remember how we talked about long? Separate the base wider, you can have more center of gravity for climbing. It has the motor up front, which is great. It's still, if you look at it, it's just barely ahead of the axle at its center line, so it's very far forward. I've taken all the weight out of the back completely, and I've even cut off the battery shelf. It's no longer there. In fact, I run my springs inboard of the frame rails now. But anyway, that's not the point of what I'm trying to say. The point of what I'm trying to show you here is I've done both wide axles and narrow axle. In the front, I have plus 4mm offsets on either side, and it has an 8mm wider track than the stock. In back, I've decided to keep that because what it does is it keeps those thrust vectors narrow towards the center of gravity. It maintains its diff clearance because it has a narrow track and rocks cannot protrude up into there. But what it does well in the front here is it keeps the center of gravity far forward, and now I have a wide base up front. So essentially, I'll show you, I'll draw a picture here of what the balance envelope looks like. I call it the balance envelope, but this is the base now. It goes from the outer point of tire contact to basically the outer point of contact here, but I drew it in just to exaggerate the lines a little bit and show you that the center of gravity is in the widest portion, but yet in the back my thrust vectors are still relatively close. And if I'll show you something else here, I've gone ahead and drawn in the thrust vectors here, and with the center of gravity up far, it does not have a long pivot point to get around. Now the front ones can. They can pull left or right, and you may want that. These are the wheels that steer, and if you want to be able to steer and have a lot of a steering authority, you may want to have that lever longer for it to provide torque. So it's kind of a hack, and I would almost guarantee that any of you who have widened your vehicles, if you'd put the tail end back to stock, I would almost guarantee that it would improve every characteristic about how it crawls, especially if you have a far forward CG. Now, if your CG is back here, now you've had it in the narrow portion of your base. But keep your center of gravity far forward, and then it's in a wide portion of your base. So, and this will sort of move around dynamically as the car tips and leans, and that's why it would tip over. I mean, it doesn't remain fixed. It has a mechanical center, but there's also a dynamic center that comes into play when you tip and pitch the vehicle. I hope that's helpful for everybody. That's all I got for you tonight. Always check the comments, and please feel free to add your own. I'm learning as I go, and if you guys have something you feel like I missed, please say so, and we'll talk to you all later.